Okay, so once everyone gets back in, then we will just do, because everyone had the exact same question. So we'll just kind of make sure everyone got the same answer. And then we'll continue on with our review.
No, I just didn't put it in. Oh, sorry, my mic's unmuted.
I know you got to be careful what you say if you're unmuted. You never know. All right, so it looks like, let me make sure everyone's back in. Okay, very good. Okay, so did anyone so I wanted to use this one. So this was from room 1 because the way that they set it up is not incorrect. Okay, it's not incorrect at all. So the way that I showed you was let me get a new one here. Was so it was 1 and 4 and -3, -5, is that right? Yes. Okay. So the way that I showed you is, remember, we need 2 things. We need our slope and we need a point. So we have points, right? We're good to go there. The slope is the problem. So remember, slope is the rise. So think up and down, over the run, think horizontal. Okay, so the rise is your y values, so -5 minus 4. The run is your x values, so -3 minus 1. So you get -9 over -4. So your slope was 9/4, and it looked like everyone got that. Okay, so the biggest thing is making sure that it's y over x, because that's your rise and that's your run. If you switch it, what you're going to end up with is a perpendicular line. Okay, perpendicular lines give you a different slope. All right, so now we have our slope. And so there's 2 ways to do this. The way that I showed you is using your point slope format. And I'll tell you why I do it this way. The other is using y equals mx plus b and solving for b. Okay. The reason why I do using the point slope format is because it tells you what to do. You have a point and you have a slope. So all the information is there. If you do it this way, it's not incorrect. It just adds a step to it. So let me show you. So if I do y minus y, and 9/4 is my slope, x minus 1, and then I clean it up. Okay, so I'm just distributing, right? Then when I add 4 to this, I get y equals 9/4 x, and then 9/4 plus 4. If you do it manually, 4 is the same as 16 over 4. So, or if you do it with your calculator, it would be 7/4 plus 7/4. Okay, this is the easiest way to do it because it's done. I haven't done anything extra to it. If I use the slope intercept format, I again use, whichever set I want. And with this one, I have to solve for b. So when I solve for b, I'm still going to get, I'm going to subtract off 9/4. Oops. I'm still going to get 7/4 equals b. This is what happens is most students do this and they go, oh, I'm done. But they forget that you have to plug it back into the formula. So you get the exact same answer, right? You get the exact same answer. This just requires me to take it one more step. I have to plug my b back into my slope intercept format, where this one, it does it for me. I don't have to think about it. I have a slope, I have a point, I calculate it, I clean it up, and I'm good to go. All right, so if you learned it this way, that's completely fine. I never want to take away from you things that you've already learned and it works for you, but it has to work every single time. So if I teach it a different way, it's just another perspective. Okay, just a completely different perspective. Okay, so any questions? Everyone feel good about that? All right, okay, so what we're going to do is we're going to continue on with our review. So with the review, get this out of the way. I actually figured out I can make this smaller. So this number 2 was, remember how we took information from a word problem and then we actually recreated the equation of a line. So it's just pulling information out. And remember, your order of the ordered pair is always the number of products, and then is the X, and the Y is the dollar amount. And that will happen every single time. You'll never have to, you'll never have to switch that. It's always going to be the same. Okay, moving on. So the other thing in your review topics is just understanding domain. And remember, domain is just the value of the X term. So when you have a polynomial, there's no restrictions. So a polynomial is like, 3x to the 5th plus 2x to the 3rd minus 4. This is considered a polynomial. So when we're looking for domain restrictions, what we're looking for is what are the values that X cannot be? Well, and this is one of the questions in your My Math Lab. Move this over here. With a polynomial, there are no restrictions. Okay, no restrictions. In other words, my X's can be fractions, they can be decimals, they can be 0, they can be positives, they can be negatives. There's no restrictions. So in My Math Lab, it's going to ask you to write things in what's called interval notation. And you guys did this a lot in 1324, so this shouldn't be new to you. So if there's no restrictions, it's from negative infinity to positive infinity. In other words, it's all real numbers, okay? So in My Math Lab, and you guys, I know you experienced this in 1324, it's very particular. And so next to the answer box in My Math Lab, it'll have blue instructions. That blue instruction needs to be, you always need to look at that, because if it asks you to write an answer as a fraction and you write it as a decimal, it's going to mark it wrong. And that's, I know it's super frustrating, but it's very specific. It's a computer program. It's very specific. So you have to make sure that you pay attention to how they want you to write your answers. Okay, so polynomials, no restrictions. When you have a fraction, so for instance, if I had a fraction 3 over 0, what would this be considered? What is that? Does anyone know the term? Can I do this?
No.
Okay, so it's called, yes, Genevieve, good. It's called undefined. All right. Now, the reason it's undefined is because, remember, a fraction is just a division problem. So if I said 3 divided by 0, well, I can't do it, right? There's nothing I can multiply 0 by to get 3. So that's why it's undefined. There's no definition to it. All right. So with the restrictions, you cannot have 0 in the denominator. All right, because that makes it undefined. I can have 0 in the numerator. That's not an issue. If I had 0 over 2, that just equals 0. Okay, so the numerator is fine. It's only the denominator that you have to worry about. So what you're going to do is you're going to set the denominator to not equal 0. Okay, so an example of that is, here's my denominator. I'm going to set my denominator to not equal 0. And then I just solve it. I add 3 to both sides and I get 3 cannot be, I'm sorry, X cannot be 3. Because if I plug 3 in here, 3 minus 3, that gives me 0. So in interval notation, what I like to do is write this out on a number line. So remember, open circle means it's not included. So what this is saying is I can use all values that are less than 3, and I can use all values that are greater than 3. I just can't use 3. So again, the way MyMathLab works is sometimes it says all reals except, and you have to plug in the value 3. Or if it says write it in interval notation, it would look like this. All the values below 3, and that's a union symbol, all values above 3. Notice I'm using parentheses. Parentheses means it's not included. Okay, that's why we have a parenthesis on the infinity, because infinity goes on forever. It's not a set number. A bracket, which we'll use in a minute, is the value is included. Okay, so this is what you would use for interval notation. All right, so same thing here. Notice I'm not even looking at the top. I don't even care about the top. All I care about is that that denominator cannot be 0. So again, using your algebra skills. So that's why I say this class, you have to make sure that your algebra skills are on point, because I'm not going to spend a whole lot of time walking you through why we do it this way. So x cannot be -3/7. So again, if there was a number line and I had -3/7 here, it would be all the values below and all the values above. Okay, so in MyMathLab, it may say one scenario of the answer is all reals except, and then you'd put in -3/7. Or, excuse me, if it was interval notation again, it would be all the values below -3/7, and all the values above -3/7. Okay, so everyone good with that? Okay, these two are going to be solved exactly the same thing with a radical. So, you know, a radical is a square root, cube root, fourth root, whatever that is. It's those roots that we're looking for. So with a radical, you cannot have a negative value under an even indexed radical. Okay, so what that means is if you had, get rid of this, if you had square root, that's even because there's a 2 there. If you had fourth root, that's even because the index is 4. If you had 10th root, that's even. So this only applies to even indexed radicals. And the reason is because if I had the square root of -4, right, what I'm asking for is what is the one number that when I multiply it together twice, I get -4. Well, it's not the same number. In order to get -4, it's -2 times 2. Those are two completely different values. So that's why I can't have a negative underneath my radical, my even indexed. Now, if I had the cube root of -8, so now this is an odd indexed, this I can do because -2 times -2 times -2. So -2 is the one number that when I multiply it by itself 3 times, I get -8. So this works. This does not. So that doesn't work. So that's what the even index means. So what you're going to do is you're going to set your radicand to greater than or equal to 0. So what that means is all the positive values and 0. So I can have the square root of 0. I can have the 5th root of 0. That works. I just can't have a negative underneath. Okay, so to solve that, you're going to set your radicand. So the radicand is the value underneath the radical sign to 3x minus 1 has to be greater than or equal to 0. And then you just solve. You just solve it like you normally do. Add 1, divide by 3. So on this one, my x is going to be greater than or equal to 1/3. Okay, so again, MyMathLab could have you answer in an inequality. It could have you answer, if you were doing this on a number line, it would be a closed circle now because it includes. So in interval notation, it would be close or the bracket 1/3 to infinity. So it's all the values greater than and equal to 1/3. Okay, now this one, the restriction doesn't matter. There are no restrictions. I can have a negative underneath there. That totally works. This one, I can't because it's an even indexed. So x minus 3 greater than or equal to 0. I add 3 to both sides, and I get x is greater than or equal to 3. So in interval notation, again, it would look like that. Okay, with a log. Oh, any questions? The even indexed is a little tiny index number, but it's easily missed. So if you get something with an odd, there is no restrictions. Okay, so with a log, same exact thing. You cannot have a negative value. So you're going to do the exact same thing. Set the log to greater than or equal to 0. Okay, and remember, a log is just an exponent in disguise. That's all it is. So we're going to set the log. So this is 2x minus 5 greater than or equal to 0. So exact same thing, nothing different than the radical. So x has to be greater than or equal to 5/2. Okay, so in interval notation, it would look like this. That's an infinity sign. Okay, so I think there's 2 or 3 questions like that in your My Math Lab. And I do check to see who's taking me seriously when I say, please don't put this off and not do it. So I think there was only one person that actually got into the review homework from Tuesday. So please don't put it off. I'm telling you, this class takes a lot longer to do your homework than you expect it to. So carve out the time to get it done way in advance of Monday. Don't wait till the weekend or don't wait till Monday. You should be getting in and doing a few problems every day. Okay, so for this one, this is the difference quotient. So you saw this in 1324. It was pretty early on in 1324. So well, I know in my class, one of the questions was on the final exam. So you have seen it. Sorry, my dog. This is the joys of working from home. Katie. So the difference quotient is just a slope. That's all it is. Okay. If you remember, if I had, a line and I wanted to know what the slope is between here and here, and this value is x, and this value is x plus h. Okay, so that h is just this distance. Okay, the h is just the distance between x and x plus h. So for instance, if x was 1 and the difference between 1 and this value x plus h was 3, the h would be 2. There's two steps, right? 1 plus 2 gives me 3. So this is just a kind of an abstract idea of what the slope is. So this value right here would be f of x, right? Just your y value. This value right here would be f of x plus h. Okay, so what you're doing is you're finding the slope. You're asking what's the slope between these two values. Well, that's where we get this. The y minus y, so I have the y minus y over the x minus x. Well, if you notice down here on the bottom, your x's cancel each other. So that's why it's just x plus h minus f of x all over h. And this is your difference quotient. And we're going to use this quite often because in the next week when we do the definition of the derivative, this is where it comes from. Okay, so this is where this difference quotient comes from. We're just looking for the slope. Okay, and remember in my math lab, we did the 3-step process. So when you look at A is telling you, okay, you're going to take the x out and you're going to put in x plus h. So when you look at this function right here, you already know what the slope is, because difference quotient, we're just looking for the slope. So do you know what the slope is of this equation? The 3x plus 1?
3.
It's 3. Yeah, because that mx plus b, right? Y equals mx plus b. So we already know what our answer is going to be. Our answer is going to be 3. How do we get that? Well, this is A. We take out the x and we plug in x plus h. And so this whole difference quotient is a practice in algebra. That's all it is. Can you do the algebra, right? Algebra is just, can you do the process? So we distribute the 3, we get 3x plus 3h plus 1. This is the answer to A. All I did is I took out my x and I plugged in x plus h. B says, take that answer and subtract off the whole thing. So I'm going to take this answer and I'm going to subtract off the whole thing. So the parentheses are important. If you don't put the parentheses in, look what happens. All I'm subtracting off is just the 3x. So make sure you use parentheses, because that indicates, okay, that negative has to go through both of those. So I end up with 3x plus 3h plus 1 minus 3x minus 1. So that negative gets pushed through, it changes both signs. Now I can cancel. So all I have left is 3h, and that's my answer to B. Okay, and then the last step says now just factor off an h. So I take my answer from B, I divide off h. In this case, because it's all multiplying and dividing, I can just cancel. So my slope is 3. So if I were to graph this, my line crosses at 1. I go up 1, 2, 3 over 1. There's my line. Oops. There's my line. My straight lines are not very good. Okay. So what that means is, I really don't like that at all. What that means is that anywhere on my graph, my slope is 3. Doesn't matter. It's 3 throughout that entire line. Okay. So that's easy to find, right? And the process is easy to do. Where it gets complicated is now I have a parabola. Okay. Remember, a parabola either looks like that or it looks like this. Because our first term is positive, it's going to look like that. Okay, so now we have a problem. If I wanted to know what the slope is here, it would be a negative slope. If I wanted to know what the slope is here, it would be a positive slope. So now we have an issue. It's not the same slope throughout the entire parabola. So this is where we use our difference quotient. So same exact thing. We take out our x. A says take out our x and plug in x plus h. And if you were in my business algebra class, I'll remember specifically telling you, you're gonna see this again. This is something that pops up all the time in the first part of business calculus. So make sure you pay attention. So you probably should, well, you should have done it so many times that it is second nature to you. Okay, so here's a shortcut. This x plus h shows up a lot, x plus h squared, okay? This is generated because you're taking x plus h times x plus h, okay? So using FOIL, I go x times x is x squared, x times h times x, and h squared. So I will get x squared plus 2xh plus h squared every single time. Memorize it. It'll save you a ton of work because this comes up a lot, the x plus h squared. So now I can replace that x plus h squared with this. And then I just distribute my -3, distribute my -3. And now I'm going to come back and distribute the 2x, the 2 through. And then I just finish it. This is the answer to A. All of that is for A. Okay, so any questions so far? All right, do you guys remember it? Is this stuff you remember? Okay, so B says take what you got for A and subtract it off. Subtract off the original function. So again, if you get anything other than terms with H, you did something wrong. So remember, you're subtracting off this whole thing. So what that means is I end up with a -2x squared, a +3x, and a -5. It just flips the sign because you're pushing that negative through everything. So now I can cancel. My 2x squareds go away. My 3x's go away. My 5's go away. And all that's left are terms with an H in it. If you have anything else in step B, then you did something wrong. You probably didn't push that negative through everything. And I can't stress this enough because I see it over and over and over again. Whenever students are doing this, they'll have like a +5 at the end. And so you missed the part that said if you have anything other than H terms, you did something wrong. So B is always H terms. Okay, and then C says take the H out. So I'm going to take this answer and I'm going to factor out an H first and divide it by H. Now I can cancel. So my difference quotient is 4x plus 2h minus 3. So remember the H? Where'd it go? Remember the H up here? And I said, if this was 1 and this was 3, the H would be 2. That H value is a distance that you don't know what it is. In calculus, what we're doing is we're taking that H to 0. We're getting it very, very close to 0. And so then I can find the slope anywhere on my graph. So for instance, if I wanted to know, get back to here, if I have this, let me see if I can do this real quick. So one of the things that is always kind of unnerving for an instructor is to show too much technology because students take advantage of that. And so technology should only be used to verify your answer. That's the only time you should use technology. You should never use technology to get the answer because you're not understanding the process of how to get the answer. Okay, so here is our parabola, the 2x squared minus 3x plus 5, right? It's pretty straightforward. So let's say I want, let me get the color here. Let's say I want to find the slope at -1 right here. I want to find the slope right there. Right here. Right at that particular point. Okay, so what I'm doing is I'm looking for the slope at that particular point. So what we're getting into is the calculus. The calculus says it's the derivative is the instantaneous rate of change. So remember our difference quotient, sorry. Wait, what was it again? I gotta go back to it. Hang on. Someone help me out. 4x, 2h, -3. Okay, 4x was close. 2x. 2h negative 3. Okay, so this was our difference quotient. So if h goes to 0, so if h goes to 0, what this ends up with as 2 times 0. So this ends up with 4x minus 3. This means that I can find the slope right here. So if I plug in negative 1 into my difference quotient, I get negative, or 4 times negative 1 is negative 4, minus 3 is negative 7. Do you see how this is a negative slope? So I'm able to find the slope at a very specific point. If I wanted to find the slope right here, the slope of this line right here, I would plug in 2. 4 times 2 minus 3, and I get 8 minus 3, which is 5. You see how it's positive? So it's positive right here. Okay, so using the difference quotient, when my h goes to 0, where it closes down to where I don't have any distance between the 2 points, all of a sudden I can find the slope anywhere on my graph. And so it's a super powerful tool to be able to have the difference quotient. And then later we'll turn it into the derivative. Okay, so that's one place that you will use the difference quotient. It is a process. It's something that just takes time. You have to be organized. This is terrible writing, but you have to be organized. You have to be clear. You can't lose negatives, right? You have to know, oh, my answer for B will always be H terms, and then I can factor out an H and get rid of it. So the difference quotient is going to be a big part of this section. Okay, so any questions? It's definitely an exercise in algebra because you're distributing, right? You're adding like terms, you're factoring. So there's a lot going on in these difference quotients. Okay. All right. So the other part of the review, and we've got just a few more minutes. The other part of the review is remembering maximum and minimum, finding maximum and minimum. So remember, when we're dealing with a parabola, we're dealing with a quadratic equation. And a quadratic equation always has the x squared as your highest exponent. So this is your quadratic. Okay, so you have a maximum, or if your quadratic has a negative first term, then you have a minimum. Okay, in order to find the maximum or the minimum, you're going to use and find the vertex. Okay, so the vertex, remember, is your highest point or your lowest point. And you use the same technique to find the vertex. And this is your vertex formula. Okay, so vertex formula to find the x value of your vertex, you're going to use negative b over 2a. So remember, that's how you get your a, b, and c. And then to find the y value, you plug that answer back into the original equation to get the y value. Okay, so that's your vertex formula. So just kind of reviewing, you have your revenue. Your revenue is the price times the number of items. So for instance, if you have, 100 shirts that you're selling and you're selling them for $10 each, your revenue is 100 times 10. The number of items times the price of the item. So that's $1,000 in revenue. Okay, so revenue is everything that comes in. Maximum revenue is the vertex of the revenue function. So here's your revenue function, 7x minus 4x squared. Oops. So your revenue is, I'm going to rearrange it so it's in descending order. Okay, here's my A, here's my B. So to get the maximum, the minute you see the term maximum, you know you are getting the vertex formula. Okay, you're going to use the vertex formula. So x equals negative b over 2a. B is 75. A is negative 4. So 75 divided by negative 8. Oh, sorry, negative 75. See, don't forget those negatives. So 75 divided by 8 is 9.375. Notice I'm not rounding. Okay, the X is in million items. So it's 9.375 million, or if I move this over and multiply by a million, that means my decimal just moves over 3 or 6 places. So it's 9,375,000 products. Okay, 9.375. All right, now I'm going to get my Y value, I'm going to plug that back into my original equation. So negative 4 times 9.375 squared plus 75, move this over, times 9.375. And then I'm just going to calculate it. So this part right here is negative 351.5625. Don't round, never round. And then plus 75 times 9.375. So this is 703.125. And then when I add those two, I get 351. So it's half. Okay, so this is my Y value. So remember how we set these up? Remember the X is the number of items. So it takes 9,375,000 items to make a maximum revenue. So this is your dollar amount, a maximum revenue of 351.56 million. Okay, so again, if you want the actual number, you multiply it by a million because this is in dollars. Okay, so that's how you're going to use your revenue, maximum revenue, and or minimum revenue. Maximum revenue is the vertex formula. So there is one question in my math lab that you're going to have to use the vertex formula to get, and then you can go from there. So the questions, find the output, and remember output is number of items. So it is 9.375 million. What is the maximum revenue? Is 351.5625 million. And then what's the wholesale price? You're going to put that 9.375 because that's how many products we have. And we're going to find out what the price is. So you just calculate it. So this price demand is the price function. So it's going to cost 37.5. So 37.50 per item to get our maximum revenue. Okay. And then I know I'm running out of time. Real quick. This is just being able to change a radical to an exponential or a fractional or rational exponent. So here is the general layout. Your index is the number here. If there's no number, it's a 2. So cube root, square root, fourth root, fifth root. The radicand is here. And then the exponent is here. Okay. So the way it changes is the radicand is your base. The exponent is the numerator, and the index is the denominator. Okay, so you literally take the index, you put it right underneath your exponent. And what this does is it allows you to change a radical to a fractional or rational exponent. So I take my 3, plug it right underneath, So this becomes x raised to the 2/3. So this is an exponent. This 2/3 is an exponent. Okay, same thing here. My index is 4. I bring that right underneath. So it's x raised to the 3/4 power. Okay, this one, the xy is under the radical, the 2 is not, so 2 is being multiplied by this whole thing. So this is xy to the 1st power. The index is a 2, so it's to the 1/2. So this xy, let me do it a little bit bigger. This right here is to the 1st power. Your index is a 2, so that's where it becomes to the 1/2. Okay, now you have to get real comfortable going back and forth. If you're given a radical and it's telling you to write it as a rational exponent or a fractional exponent, they use both those terms, then you're going to do what I just did. Bring your index right underneath and it becomes an exponent. Or you have to go in the opposite direction. So this is 36 raised to the 1/2, which is the same as the square root of 36 to the 1st power. Okay, so you need to be able to go back and forth, back and forth, back and forth. And you're going to get so good at this that it's going to be second nature to you. But when you're just starting to see it again, and it depends on who you had for 1324, whether they really push this concept. So if you haven't seen this before, just practice, 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 practice. So this is the square root of 36, which is 6. This is, so remember, this bottom number is your index. So it's 125. Okay, so when it's written out like this and there's a number other than 1 at the top, I always get the root first. So in other words, I do it this way. I do it in 2 steps. I get the cube root of 125, which is 5, and then I apply the numerator, the exponent to it. So 5 squared is 25. So this 125 raised to the 2/3 is the same as the number 25. And you just break it up. So here's another example. If I had 8 to the 2/3, I would take the cube root of 8 first, which is 2, and then I apply my exponent. Okay, and I really did do the same thing up here. I did the square root of 36 is 6. 6 to the 1st power is just 6. So I do it the same way every time, but if it's a 1 at the top, then I know it doesn't change anything. Okay, if you had, let's see. If you had 3125 to the 3/5, it would be the 5th root of 3125, which I just did, is 5. And then I put that exponent on. So 5 to the 3rd power is 125. Okay, so it's just another way to write it. The reason why we have to have that is because you cannot find a derivative of a radical. You have to have a way to change it so that you can find the derivative of it. So that's why you have to know how to change it and go back and forth. Okay. All right. I know that was quick. Any questions? Hopefully all of this will be has been review for you, just kind of, remembering how to do these things. If it's not, remember in your, and I'll fix this OneNote link, because I just saw it and remembered. In your modules, remember there's always resources. So the resources are there on the review topics that we just went over. Okay. All right, guys, have a great weekend. I will see you on Tuesday, and let me know if you have any questions. Have a good weekend.
Thank you, ma'am.
Thanks.
Bye, miss. Have a good day.